Well, hi, good morning. Thanks so much for joining me in my shop here on September 2nd, another fall-like day here. My gosh, it's like somebody threw a switch and we just went from summer to fall, just like that. So just a word here about my videos and my style of doing stuff in here. Remember, you're not watching somebody showing you stuff, you're watching me try to figure things out for myself. So you're welcome to come along for the ride, that's fine. I have a certain style that I approach things with, everybody does, and mine might be different from yours or others. Part of my methods here, when I'm facing something I'm not all that familiar with or don't have too much experience with, is to just go ahead pretty early on, whip everything together in whatever way it's supposed to go or maybe go, and make some observations and get some stuff happening and not worry about an effective result initially. Not on the first pass. I mean, if it works out, great. If it doesn't, that's great too, because it's just the process of me getting a grip on things. So that's what happened yesterday when I hooked everything together and got absolutely nothing to work. Well, I shouldn't say that. Got a nice display on the scope, but could not get the marker pip to show up. I was doing something which I myself thought was kind of weird, which is trying to pump 10.7 right into the antenna connection. But I'm trying to follow the instructions that come with the receiver for doing an alignment as much as I can, while at the same time trying to get this guy going. I made a few notes this morning of things I remember from yesterday. So one of them is, one of the deals here is I'm not sure what the output level is from here. Now, in the manual it says it's, I think the max is 1/4 volt, and it's down from there. So I don't think there's an awful lot there, but that's something I'm not, the machine doesn't present you with something obvious about what the level is. So that's one thing. The next one is, did I ruin my big signal generator here? At the end of the session yesterday, I noticed the meter was pinned right over, pinned way over. And even when I turned the unit off, it sat over, which is really weird. And it did slowly come down, and if you see it now, it's sitting on 0 again. What exactly happened there, I don't know. It's possible I fed a signal back into it because I had this output and that output parallel, each one feeding kind of back into each other. I didn't think the levels were high enough to be concerned. Maybe there's something else going on. Maybe it failed on its own, just coincidentally. Oh boy, so we gotta figure out about that. Now, another thing is the manual for this signal generator comes with instructions for building a terminated output cable. So the output cable comes along, and at the end of it is a, I think it's just simply a resistor right across the ends. I think it's a 50 ohm resistor, and it gives you a properly terminated cable at that point. I'm not doing that. I'm using just an open cable. It's terminating in the little circuit I have soldered in there, a little test circuit. Yeah, 10.7 into an antenna. So in a lot of these radios, you could probably push a 10.7 signal from the antenna right through the front of the radio and get it into the IF. It's possible. It's also quite possible you can't do that. There's way too much filtering. 100 megahertz and 10 megahertz, they're far apart. And there's even circuits in a radio like this to trap signals like 10.7. Maybe as they leak out towards the antenna, there's a trap to kill them. So if you try to put them in through the antenna, there's a trap that's going to kill it. So not too sure about all that. I mean, there's another whole approach here, and that is instead of using 100 megahertz in the antenna, we try to pump the signal right into the IF strip at the IF frequency. And this guy, you know, he could do that. He's got a 10 megahertz setting here, so we could sweep around there. I'm not too sure what would happen with that. That's a step I'm not quite ready to take yet. So what to do? I think maybe I'm going to turn on my signal generator here and watch what happens. Watch the meter. See if it just goes right over. It's up. It's up. It's up and down. It's up. All looks normal. Whew. So I think I came close to doing something bad to that signal generator and got away with it. I see the meter's dropping a little bit, but I guess that's just the warm-up process. This is a great signal generator. It warms up dead on the frequency. You turn it off, it's dead on. Never drifts. Wonderful machine. Okay, good. I haven't ruined that one. Maybe the next thing to do is to try to see, what I discovered yesterday, or appears to be the case, is the attenuator didn't seem to attenuate anything. It was also very, very odd, because this is a very simple thing, and I don't see how it can't work. So maybe one of the first things I want to do is look at and measure the output from here. And as for the wave shape that I had on the scope yesterday, the question would be, is that really the wave shape of the overall response of the radio, right through the IF? Or is that messed up by various things I've done here that aren't quite right, including not having good control over the output level on here? Don't know. Okay, so this guy is stabilized normal. Thank you very much. Now, how am I going to avoid messing it up again? So this is the output from this signal generator. I do have a protective device of a sort sitting right here. You see the box. So that's a antenna simulator, and it also has a series capacitor in it, so there's no DC exchange from whatever I'm testing back in. It also changes the impedances of, it terminates the output cable from here in 50 ohms, so it's happy. And the other side of it is around 300 ohms, depending upon the frequency, 200, 300 ohms, like an antenna. So the radio's happy, like it's connected to it. Now there is an additional circuit in this too that I'm trying to ignore, and it should provide a much more effective pip output from here, if I can get there. What's next here? Checking the output of this, finding out what's going on with that. So let's switch it on. Right here. I have the crystal out right now. Now, normally this machine is running with an awful lot of harmonics or repeated frequencies going up the band. So it's not putting out a single frequency in many modes of operation. It's putting out a whole raft of signals, and that can be very helpful. It can also be confusing at the same time. Okay, so is it even working? I mean, it should be. No reason why it wouldn't. Let's find out. I think you hear it right there. Yeah. Okay, that's enough to know it's working. Put the sweep down. We're going to take the output here, the unterminated output. I think I'm going to put it right on the scope, and we're just going to take a look at it. We're going to see what is up. My scope is good too, I think 100 megahertz. But we don't have to run this at 100 megahertz while we're experimenting with its output. Put the sweep on. So I am going to turn the speed or the frequency way down on the signal generator. Oh, that's turning it up. Let's change bands here. Okay, we're gonna. Well, you know what? Let's experiment with the 10, the band with 10 megahertz on it, which is the A band. 10 megahertz. Be down around here somewhere. Okay, let's speed this up. Well, that doesn't look right at all. I can see a little bit in there. I know it's not coming through on the camera, but not looking right at all. So how far? I can go a little bit slower or lower here. Let's go down to around 5 megahertz. Now that's interesting, because the sweep generator can operate at 5 megahertz. I have a 5 megahertz crystal. Okay, again, this just doesn't look right at all. So I'm triggering on the line right now. Let's see if we can actually trigger my problematic guy. There we are. Okay, so that, now, let me turn this down a little bit here because it's too bright. Very tricky to get this on camera. Let's try this one. There. Well, that doesn't look right at all. That does not look right at all. I'm expecting to see basically a sine wave there. Okay, first of all, marker generator off. Vary the frequency of the sweep. There's nothing going on the scope there at all. There's nothing happening. So what are we looking at here? Attenuator? Well, interesting. So if I turn it slow, well, this is a little unexpected. Let me just pull this off the radio here because it's I did something unusual there. I didn't expect that. I left the output clip lead connected to the radio, just one clip lead. And I took it off, and this is just so something coming out of the radio. The radio's not on. Yeah, but it could be picking up all kinds of stuff. Let's go down here. Okay, so we are on max output from the sweep generator running somewhere around 5 megahertz. We're getting 0 here. Okay, so I made my scope quite sensitive. I think that's just a bunch of noisy hash. What about this? Okay, so that's changing the times 1 times 10 on the probe. This is not happening. This is not happening. Whoops. The whoops was me pulling out a camera wire here. Just okay. Hey, everything's going downhill pretty quick here in the shop today. Well, what to do here? I'm a little surprised. Let's try the radio here again. It's a shortwave radio. It can go down to 5 megahertz. Let's do that. Five. That's 5 megahertz. FM 100 megahertz. I think you can see the scope. It's doing something over there. Something's coming out of here. Well, let's stick with the 100 then, and we'll look at the scope again and see what in heaven's name is it saying here. So, what is that all about? So now I'm triggering on the 60 hertz, and you can see it's frozen the image there. Let's slow it down a bit. Well, yeah. So a few things I was going to say. One is we're seeing the blanking operate. Well, I don't think that's possible. It's supposed to blank on every half cycle of the... No, it blanks on every half cycle of the 60 cycles. During the retrace. So that's showing the blanking operating. This isn't, you know, there's stuff in my head that's not adding up here. But so let's change the frequency here. The output kind of disappeared. I got down to the bottom of the range. Actually, this is going up. This is up around 200 megahertz. Coming down. There's something funny right in there. Lots of weird stuff happening. Right in the middle here, you can see a small square peak show up. But then as you go higher, it turns around and becomes oh. Okay. Fine attenuator. Good. Notice it doesn't take it to 0. Times 1 times that. Well, that's working. That's perfectly working fine. And what is the output level? Okay, so we have fine attenuator turned up. This is max output here at this frequency. Anyway, so on the scope, we're on looks like 20 millivolts per division. 20 millivolts per division. That's not much output, is it? So that's 20, 40, 60. 60 millivolts. That's way below where it's supposed to be. I'm pretty sure this is supposed to be, well, the manual's somewhere else. 1/4 of a volt. Kind of stumbling over my wires here. Okay, let's try another band. A C band. You have more output, changing the sweep frequency. There's those funny little divots in the top again. B band, more output yet. Use the attenuator to drop it down. A band where we want to be. Oh, okay. Attenuator back up. It looks like there's a little bit there. Moving the sweep frequency around. So the band I went to use, there's not much there. If there's anything there. So did not pick it up on a shortwave radio. Oh boy, I tell you, at every turn. Now you know what? 10 appears at another spot on this. It appears in band B. Band B, I'm up around 10. Good. So I'm assuming it's around 10. I can get quite a bit below the 10 marking. Good. We'll probably find 10.7 in here. Which means I should be able to use the sweep to sweep through the IF directly if I choose to do that. As for the A band, I'm trying to use the 10 on the A band. It's also at the extreme end of the A band, so not going to have it, but that's good. Okay, it's an option. Checking the attenuator again. Oh yeah, very strong attenuator. It's a times 100 attenuator. It's not a. Usually you're going down in steps of 10. This goes down in steps of 100. Okay. Now feeding this signal into this radio in the appropriate place. Or yeah, I gotta. Whoop. Okay, so I just knocked the camera off again, but you're not looking at the camera, so what does it matter? Okay, I'm not looking at the camera, I keep knocking off. See me standing still there? Now, let me just correct that. Here we are. Okay, I'm going to look into how to attempt an alignment with the 10.7 signal going right into the IF here. See if I can find some direct instructions in the manual for the receiver on that. Well, we just peek at the alignment instructions here. Signal generator coupling via a 300 ohm matching pad to the antenna terminals, and here they're suggesting one here. Now, I haven't done this. I am not using a matching pad, and I'm not using a properly terminated. Look, they've got a 56 ohm resistor here terminating this coax, so I should probably make this circuit up. But it's this way all the time. The signal generator is always fed in. Is it? This is the multiplex area. Connect composite signal generator. I have one of those, believe it or not, to antenna terminal through matching pad, as in FM alignment. So every time you're doing this, you're feeding stuff in through the antenna. I'll make up this matching pad, but I don't think it's really going to solve everything here. Now look at this next instruction. Signal generator frequency 108 megahertz, because you're up at the top of the dial to start with. I'm doing this at 100. It says a 108 megahertz sweep mode, sweep modulation. I guess that's what they're trying to say there, because in a sense you are modulating an FM signal. Sweep modulation and 10.7 megahertz marker into the antenna. Signal generator output to be adjusted at all times below overload output level. This is a bit of a challenge, recognizing when you're causing an overload in the receiver, and I think more difficult is knowing you're not causing an overload in the receiver, which will change the shapes of the response curves. So I've got this test detector probe. I'm using this one here that they are showing. This is keep leads as short as possible. I've soldered these two leads right into the radio. They can't get any shorter. I guess they're, and optimal amplitude and symmetry of IF bypass bandpass curve, of course, to be adjusted away from each other, which I still don't quite understand. Well, it seems to me I'm doing things just as it suggests. I mean, aren't they suggesting here stick 10.7 marker frequency into the antenna? I tried that a couple different ways yesterday and got nothing out. Okay, there's such a series of things here that could be causing trouble. The least likely one is this one, but this is the easiest one to correct and eliminate. And so this is the curve I'm trying to duplicate. And what I'm trying to do is to be able to mark this point 10.8 here, and mark this point here, and see that this is roughly the right shape. I guess at that point it's eyeballing it. There's some more markers down here, but I don't know why they didn't label them. I don't exactly know what there's. Well, I guess it's just the same thing again. So you have 10.7, 10.8, this would be 10.9. So that's to help you assess whether the shape is correct. And that's what getting these pips on here is all about. So far I'm the only pip here. Okay, I'm going to build this little circuit here, and the interesting thing that does, that lifts the ground off with a 150 ohm resistor here. FM antenna terminal. What's this? Terminal. FM antenna. There's two binding posts on the FM antenna. Terminal. They use that term anywhere else? They use the term anywhere else? No, they don't. Jeepers creepers. Well, this is either, either it's onto the FM antenna, or they're trying to suggest that this is connected to the chassis. I don't know what to think of that. Sometimes the simplest stuff, eh? Okay, time for a little more coffee, I think. Okay, let's take a look at the book here. It has this nice diagram. So one connection from the signal generator over to my scope is this horizontal output cable, and that's this wire you see here coming from down here. There we are, and that's what's giving the sweep, but not right now. Right now the scope is using its own internal sweep circuits to generate that kind of sweep. So that's correct. Now they show the RF output, and this is going to a TV receiver, but it may as well be a radio receiver. They don't show it going to the antenna, they show it going into the mixer grid, kind of where you would expect to feed that. And of course you'd be feeding it at the frequency of the IF in the television, which I don't think is necessarily 10.7, I don't know what it is. Then here they are, grid of the first video amplifier. I'm not going to say too much about that because I'm not a television guy, but again, the manual for this radio specifies what I've done here, exactly what I've done. So I think that's basically the same thing as this. And then you have it going to the vertical, which I do, which I take my clip when I use it, clip it over to the vertical. This has to be set to XY to make this thing work from the generator. So the thing is, this is not going into an antenna. This makes more sense to me. So getting this guy to work at 10.7 is I think, the key to it, regardless of the fact that the receiver instructions say punch it in at the other thing about the receiver alignment instructions is with the signal going in at 100 megahertz, there are non-IF adjustments that are being made. So they're basically combining the process of doing the non-IF adjustments and the RF adjustments kind of at the same time with the same signal going in. So under this arrangement, with signal going in at the antenna, I could do the RF adjustments, but I'm having a heck of a time trying to do the IF side of things. Pumping a signal right into the middle of a circuit like this is a little bit precarious. You need to take a few precautions, capacitors in the right place, and you certainly would want your instrument to be set up properly. This one, so in the manual here they also have something I kind of overlooked at this point. They have what they call a compensating scope lead. Here's a diagram about it. So this is actually going to the oscilloscope. You're building your own oscilloscope lead, and in here is a fairly large resistor in series and a capacitor across the far side filtering. This is a filter, and it says on it, it reduces the RF that the scope is facing. Okay, not exactly sure why that is, but I don't have that. My scope lead is just one of these. It's not compensated in any special way. I do have a times 10, but my understanding is that that's nothing more than a resistor going in and out in here. I don't think there's any capacitor in here at all. The scope lead itself has some capacitance, but it's very small. Because the capacitor they're suggesting was, and I gotta look again, was a fair size one. It was a 1000 picofarad. 1000 picofarad is 1 nanofarad, 0.001 microfarad capacitor. So that's a fair size, and that's, yeah, a lead like this is a couple picofarad, 10, maybe 20 if it's a lousy one. I think so. There won't be enough there on its own. So we try to make these changes to it. The easiest one is just to throw the capacitor in here. A 0.001. Let's do that right now. I'm just going to whip this together again. I'm not going to sit and build this stuff out. Not yet. Is that a 0.001? 0.001. That's a weird looking guy. Okay, we can just put them right like this. So what it did on the scope, I'm sorry I didn't have the scope showing, is it reduced it when, like that. Now I could put this on times 10. I think I've done this wrong. So I think what this does, it puts the capacitor out front ahead of the resistor. So that's really not going to work all that well. Hey, look at this. This is a small resistor, I think. Yeah, this is a very small resistor. Let me get a bigger one. We'll fiddle around with it here. How about one like this? How big was the resistor that they were recommending? 56K. No, I get somewhere up around 56K. How about we use 56K? Let's see what we got here. 56K. Here's one. Nice. Look at that. Great big honker. Okay, 56K. And the idea is it's in series with the scope lead. Make sure this is on times 1. Put this on here. These wires sticking out here. What do we got? We got nothing on the scope now. Make it more sensitive. Ooh, that doesn't look so good. It looked better before. This is all up full. And it's not hooked up to the radio in any way. This is just the output I'm looking at. Well, it really, really knocked it down. But then this is all RF. And basically what we're getting the scope ready to do is show us something. The RF part is not going to be important. Maybe. Sort of. Kind of. Put this back on the antenna. And put the scope back on the output of the receiver. Goodness knows that this isn't going to help at all. Okay, back on the output. Receiver's not switched on. And then this, I want this hooked up to the antenna somehow. Wait a minute, this is the scope. Wait a minute now. So all this is supposed to go on that circuit? That circuit is already built for the scope. Where is this supposed to go? Scope lead. Built-in scope lead. So there. Oh yeah, that's right. There's two different manuals here, two different sets of engineers. Yeah. So each one is setting up the same scenario. But over here, they set up a resistor that I'm connecting across, and that's a 15K. You know what? I don't need these. This is already done. Just by using this circuit, this has been done. Now, there's no. Yeah, it's all. I guess what they're anticipating is you're using this instrument and you're using their instructions and you've got nothing else in hand and you've got a receiver over here, so you're going to rely on the instructions from this guy to make connections to it. So they're including the compensation in the leads when the compensation is actually for this receiver in the little circuit I made there. I think that's what's going on. Goodness knows. Okay. Is it okay? So we're going to try pumping it in the antenna again. Why am I even bothering with that? Why am I even bothering with that? When the instructions in the manual say, the manual for this says, shove me into the IF. And the manual for this says, shove them into the antenna. I shoved them in the antenna and didn't get the result. Let me look a little further into how we would inject a circuit into the IF here in this radio. Maybe there's a spot. Maybe it's talked about in the manual. So the receiver manual, of course, makes no mention of any alternative other than feed the signals into the antenna terminal. That's all it says for the whole thing. So if I want to try this, I have to figure out myself where to feed the 10.7 into this receiver. And somewhere in here, but it's not actually that difficult. So the FM tuner is a box right in here. Now you see everything that runs at 100 megahertz at the full FM frequency is all inside this box. And the converter's in the box that converts it down to 10.7. And then the 10.7 comes out of the box and heads for the rest of the radio. 10.7 being a low enough frequency, it's pretty easy to handle. 100 megahertz much more difficult to handle. So coming out of the box. Now the box has nothing coming out the top. Stuff comes out the bottom through this square hole right in here. By the way, the receiver's not on, so I can put my finger in it like that. And what I would expect to find is a short cable, shielded cable probably, running from this area over to here, which I believe is the start, I'm pretty sure, start of the, you know what, this might be the finish over here. This might be the finish. The start might be way over there. But you would expect them to kind of design this so it's not a long journey. Hey, what are you doing way up there? Come on down. Ride that elevator. It's you know, you don't want to feed these signals a long ways, but so what do we got here? So we have a terminal strip. All these components here appear to be unrelated. These last two terminations are picking up this shielded cable and this brown wire. I don't know where the brown wire is going. Somewhere. So this shielded cable, we can guess, is carrying the 10.7 signal. And it's going right to the start of this board. So I'm really quite sure this is going to be the 10.7. I'm going to do something a little bit crazy here to get even more certainty about that. We're getting ready to turn on the radio here. You know what, I don't want to be in here too much longer because it's another beautiful day. We don't know how many we're going to have left here before it's just cold. So I'm going to try to pick up the 10.7 using this little radio again, my little shortwave radio. I tuned this to 10.7, and I'm just going to take the antenna. I think I'll take the insulated part of it. And kind of go like that. We'll just see what happens here. Nothing there now. Okay. Something loose somewhere. There we go. Receiver's on. Running at 119. Let's turn the sound up. Barely hear it. Barely hear it, right? That's what we're trying to correct. There's barely any signal. Of course, I don't have an antenna really connected, but anyway. 10.7. Are you in there? I'm not sure what I expect to hear, if anything. That doesn't do anything. This is a bit of a crazy idea, you know. So what if it's not 10.7? I would expect if there's a strong 10.7 signal here that the radio would go quiet. Yeah, I also think this is a dumb way of doing it. Okay, so that didn't prove a darn thing. Another way is to put it right on the scope and try to determine if that, well, if there's a signal there, I think we can bet. Wait a minute now, you can't have any signal coming out at 10.7 unless you've got a signal going in that the radio's tuned to. Yeah, so I need to have a signal going in here. Gee, I need an FM, I need an FM signal generator. Okay, we need that. So we'll try this guy for what it's worth. I'm gonna put this into here. I'm gonna clip the ground into the ground. This is supposed to have a 50 ohm termination, does not have, but that would be more for calibration purposes. So hey, look at that. That's coming out of the 10.7 radio here. So we tune this right to 10.7. Bump the volume. Sweep down. So what's happening is I'm putting a 100 megahertz signal into the radio. The radio's tuned to 100 megahertz. It's converting and producing the 10.7, which is then strong enough to trigger my radio here, which is sitting, the antenna's not even close. Okay, so we know there's, so what do we know? We know there's a 10.7 signal there. And we can tell it's the swept signal because it's got a hummy sound in it from the sweepy thing going on. Well, that's kind of interesting. What's happening on the oscilloscope? We don't really care. Now we want to change this to 10.7 and feed it into that spot. We just still don't know it's that spot. Let's see if I can figure that out. Yeah, I'm tempted to hook that right up, right on there. 0.1, a smaller one. Have anybody got a capacitor around here I could just grab onto, or you got a big resistor? How about that? That's a big one. So the radio is floating here. It's not grounded in any way. It's just, you know, it's a battery radio, so can't have too much worry here about messing stuff up, can we? Okay, well, if I had to pick one terminal and say that's the guy, it would be this terminal. Well, that's not much of a response, is it? And what other possible terminal is it? Well, I don't think it's possible it's anything else. It's got to be here. Watch the oscilloscope when I do that. Okay, so I'm just holding it by the body of the resistor here. Oh, it was a lot more exciting before. What happened? Must be putting quite... You know what's happening is this is brushing up against my finger, and when it does, I'm injecting my own hum into this whole thing. That's what's happening there. Didn't prove there's 10.7 there. It's not easy to make a contact to these particular terminals. They're covered with rosin. Oh, careful there, don't do that. Well, there's a DC potential there. 5 volts per division, so there's like 15 volts DC there. Oops. Okay, so that's the AC signal that's there. And nothing. Lots of 10.7. Must be 10.7 happening. After all, the sound does come out the speakers, doesn't it? Doesn't it come out the speakers too? Yes. Plenty coming out of the speakers. No question there's 10.7 being generated. Okay, so, but I just can't find it. So maybe I made a big mistake here. Maybe there is another wire coming out of this box. I didn't see it. No. The only wires coming out of the FM tuner going in or coming out? Going in. Going in. So here's the FM antenna here coming from there. And that's... up, pops out of this hole here. Here it is here. Oh, there is another spot. There's another hole. I can't see it here because my angle's wrong. My angle is wrong. So there's another square hole here. Let's take this off here. And the signal's coming, going in. You wouldn't think the out's right there too. Can't really see it very clearly. Just 1 second here while I apply my eyeballs to the situation. There's a little green wire coming out of there. I can't imagine that that's the output. It's got to come out on a shielded wire. It has to be here. Let's try a capacitor. A capacitor. A really small one. About a 0.005. So I'm going to put this on the end of the radio antenna that we're listening to. And I don't want to be holding on to this particularly. I guess I could hold that. I think I can hold that. Now again, the expectation is my little transistor radio will be overjoyed at the extra signal I'm going to send to it from here. Oh, I think it's overjoyed. I think that's overjoyed. I've got a signal strength meter here. Right up. Right up, and then the ABC cut it back. Okay, we're going to assume now that we can feed a signal in there. I don't want to do it. Well, we're going to use this, so we got to disconnect this from here. And run this up to that terminal with an isolating capacitor. No special compensation of any sort, nothing. We need to have this at 10. I've got the radio here already, so we'll set this to 10. Well, son of a gun, if it isn't on B. This machine produces a lot of harmonics, so I'm on the wrong band to feed 100 megahertz in there, but I certainly managed to do it. Probably because B is about say 12 here. It's probably a multiple of 12. Okay, I don't want to go back over that. I'm just going to accept what happened. We're going to flip this down to where I can get it 10 on the B scale. 10 on the B scale. I'm hoping the radio is going to report this. Great thing here. Closely couple them. Why no 10 now? I thought we saw this 10. B, off, full, sweep minimum. What happened to it? I thought for sure I got a 10 there before. Oh, I know what's wrong. This is on 100. No, it isn't. 10.7. This is on 10.7 kilohertz. Well, it's meant to go right on antennas. So 10 is right in here. Calibration's so bad. 10 is actually up here. Okay, I'd guess there's 10.7 on that clip. There's a little bit of sweep in it. Turn that one off. Now, I'm going to... So this is already grounded. No, it isn't. Let us ground it. We will ground between here and there. Would that be the first time? No, I have a ground from here up to my scope, so this grounding's nothing to worry about. Boom. Nothing to worry about. So I've grounded the lead. Now I just want to run this up to here with a capacitor. I have the capacitor here. And this is all, yes, out in the open. Let me change something first. Okay, I don't need this white clip here, and I don't need this yellow nonsense here either. This was my attempt at getting the signal to the SDR. I'm just going to get that out of there. It's just a passive pickup coil. I'm just able to ground this on the radio directly, and that's all I'm doing. Ooh, that's not so good. This lead wants to jump into the radio here. Let me do it over here. There we are. I use my clip lead, capacitor. Is anybody screaming, "Don't do it, Jim, don't do it"? Nobody I can hear. Because we got this turned down. Okay, we need some speaker action here. Speaker action, please. That's full tilt. We're not going to leave it there. I'm going to turn it right down, up a wee bit. Put this on there. There we go. So that's coming out of the speakers of the radio, I believe. Let me try it again. Right down, nothing. Turn up the speakers. Good. We're going on. We're on. So now I believe I've managed to inject a 10.7 slightly swept signal into the front end of the IF of this radio. And we can hear it coming out the speaker. Let's look on the scope. See what we got now. So little AM radios, it's pretty easy to jam signals into the antenna and get away with some stuff there. Maybe not so much with this. Okay, we're on. I'm going to put this scope. Here's the scope camera here. Okay, so we're sweeping with the scope. Let's go XY. That's XY. Let's make the scope more sensitive. What gives there? So very, very sensitive. That is absolutely not what I'm expecting there. It's almost like it's backwards. Almost. I mean, it's supposed to be a nice curve up and down. Put this on times 10 times 1. Doesn't seem to make any difference to the radio. Turning down the signal coming in. Adjusting the frequency of the signal. Volume is set quite low on the receiver. I'm pretty sure we're blasting this with an overloaded, looks like an overload amount of energy here. Turn it down lower. That's as low as I can turn it. Sweep width increased. Oh, look at that. Down, 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 down. So this is in the 0 range on the sweep. Turn it up a bit, and look what comes climbing out of there. Going up and up and up on sweep. Okay, gonna come back down. Let's try the horizontal phase control here. Phasing control. It's doing the same thing it's done before. It just kind of flips it. So I'm really not sure that's working properly. And if we increase the signal again, yeah, so it could still be overloading this guy. Well, let's add in the marker pip and see what happens now. Okay, so marker amp coming on. Marker amp is on. Now we want the marker amp to be putting at 10.7, but my marker amp lowest frequency is 19. So exactly how this works, I don't know. Let's just change the marker frequency here. Oh, go back. I saw a pop there. There's a marker. Very hard to move it through, but okay, just swinging the frequency dial. Oh, there's another one. Go back. Oh, I saw it. Oh, right in there. There it is. There it is. Now, what frequency is that pip at? Well, what it says on the marker amp frequency scale is either 24 or 72. 24 or 72. Phasing thing again? No, it just does the same thing. Flips it this way and that. Well, we have a pip. We don't know what frequency it is. Which is why you use a crystal in these things. Going back once, just going down. We're just going to keep going down in frequency here. Actually, I'm going up in frequency is what's actually going on. Up, something there. So there's a number of these occurring. The number would be maybe 3. I think I'm almost there. I'm at the top. So go back. There's one there. The frequency reading is just on the lower scale, 50. Well, yeah, around 50. And I can't be sure about the accuracy of this. Now we'll continue on until we see the next one. The next one, and now we're right around 100. Now we'll go up. Another one here. Am I seeing things in there? I might be seeing things. Oh, there's one. And what are we around now? 70. I don't think there's much pattern here. I don't think it's going to reveal anything. Okay, now what I can do though is I can use my other signal generator to supply an external signal into the marker generator. And this is where things got a little wonky yesterday. Now I've noticed something about my signal generator, my big old military one. Let's just take a look at it. So yesterday I looked over and this meter was pinned right off, and quite frightening situation. Today I turned it on, all seemed normal. Came up in this area here. Then I've been working away here not looking at it. Now I've looked over at it and somehow it's climbed to the top. And the output level, okay, wait a sec, this has to be here. Yeah, the actual output from here. Yeah, this was set extremely low. That was set extremely low. I haven't done anything with it today, so it doesn't matter. It's set low because I was messing around wondering why it had almost blowed up. Okay, seems to be okay. Seems to be okay. Let's take the output of that. We'll feed it into here where you're supposed to be able to feed it and see what we end up with. Okay, so I'm going to plug this in here. So this is where you can plug in an external marker. I should have had that on. Oh, that's not a good sign. Okay, so you can't even see what I'm doing. Turning on my frequency counter. This poor guy, sometimes he goes crazy. So we'll give him a minute or two to kind of come around. Yikes. Once that comes around, we can then dial in exactly 10.7, which is where I think this is right now anyway. We'll hook up these two signal generators together, watching the meter. So we'll go ground to ground. And these are being connected through this little box I mentioned earlier, where there is a capacitor in there. There's no DC that can flow. Okay, I'm watching the meter on my guy there. I don't see anything happening. You can hear something in the radio though. Listen to the sound of the radio. Okay, not exactly sure what that is. Can't be sure of anything until this guy wakes up. Hello there, mister. Wow, he's looking pretty upset there. So assuming that's 10.7, we are now putting 10.7 into here. We have the crystal out, so the only source, we got to turn, this guy's on. You can turn them up or turn them down. So my understanding of this is I hope I get this right. This attenuator attenuates both this generator and this generator. This fine attenuator only attenuates this one. Hope I got that right. So the level output is controlled here. Turn it up. And feeding potentially a strong signal from the signal generator. And I'm looking at the scope there. Nothing's happened yet. We're back in the mode we were in yesterday, where it looked like sticking a signal into here doesn't do anything. I had clipped this to avoid using this connector and that. I'd clipped this right into the back. Let me do that again. Even though we can hear a change when I do it, I think this is a little more certainty here. Okay. Oh, wait a minute, I just picked the wrong thing. Nope. Right behind this connector is a capacitor. Anyway, so you can't exchange DC through here. So I don't need this. Okay, man. You should be working. You should be doing something interesting now. What do we got? Okay, first of all, the marker amp is not. Oh, okay, so my signal generator stopped. It's 10.698, so that's 10.7. So there's a 10.7 signal available. Should be available in the output cable from the signal generator that is driving the receiver. It should be there. I have the attenuator. Let me do this. So fine attenuator right down. This guy up. Ooh. So I'm on middle setting of the attenuator, and marker amp full. And I certainly don't see any mark there. Now I've got to swing the frequency of the marker amp, the external marker amp I'm using, back and forth here and see what we see. See anything? Well, there's nothing whatsoever. Oh, yes there is. On the very left. Right there. Well, that's kind of interesting. What's it doing over there? 10.8 on my signal generator. Let's go back down to 10.7. Oh, there's something there happening there. Again, it's like it's like it won't climb the proper, the desired signal there. Okay, so that is happening at 10.4 or 10.5. Wow, this is pretty weird. Again, 10.7. Nobody's home. It just strikes me the display on the scope is twisted. That'd be the best way to put it. It's twisted. Okay, let's try the horizontal phase thing again. It doesn't do anything but flip it suddenly. Yeah. I'm a little wondering about that control. Sweep width. Look at this. Now we got something here to mess around with. Now that looks like the blanking isn't quite right. That's what that looks like. I don't have any way of adjusting it, I don't think. So it certainly is. So you know what? I've got things. Maybe they should be set on DC here. Let me flip it over to DC. How do you like that, eh? Smart guy. Just takes a while. Oh, look at that. Now that's fantastic. That is fantastic looking. Okay, what we wanted to do here is scope very sensitive, output from our sweep generator very low. Okay, knocking it down another 100. Looks very different again. Scope sensitivity up a bit. A little hard to look at. Some kind of pippy thing on the left there. Okay, sweep. Try to make a bigger diagram there. Now I'm going to move it by changing the sweep frequency. Move it a little bit. Other way, other way, other way, other way. Get in the middle of the sweep. Okay. Now, sweep width. Okay, I'm going to adjust the frequency and move it again. Shrinking the sweep width further. Well, you know what? I think I can work with that. So I'm sending a 10.7 signal, pip, and I'd say we're seeing it there. I'm going to change the frequency of my pip generator here, external pip generator. Let's see if that messy pip moves. And it's going up. It's climbing into the middle. Okay, so right here it's at the peak. And what is the frequency? Wow, 10.5. Is that wrong? I think it's supposed to be 10.7 is what's supposed to happen there. Is this why this receiver is so quiet? Have I made it all the way to actually being able to analyze something to do with this receiver? Have I got there? Oh, I don't need to do that. I need to do this. We see lots of noise in the signal. That means I've got my input signal levels quite low. That's what I think it means. What else could be out of sorts here? I have a long lead reaching the... let me grab this long clip lead here. Does it make any difference? It does a little bit, doesn't it? I grab it, it seems to settle. That's my hand on the insulated clip lead. When I take it off, it floats up. Now there was something about isolating the scope lead away. Okay, that's a times 10. That really killed it. Go back on. We think the circuit I've installed on the receiver does all that necessary stuff. So what if this is true, in that it's showing us the response of the IF? There's some serious problems. First of all, it's not a nice uniform curve. It's got a funny hump on the left. Secondly, it seems to be peaked way off, 10.5 instead of 10.7. Now that's 200 kilohertz off. I think that's more than enough to quiet the receiver. So what I'm going to do here today, I'm going to stop now because the next step is involved. And start doing actual alignment things. I think I've got myself to a satisfactory arrangement here with all my equipment. I think I have a valid result on the screen. I think I can start twiddling a few things. I think the receiver does need alignment. The most powerful indication is it doesn't receive much of anything. It's very weak, very, very weak. Part of what doing an alignment at this point will do is it will prove if it's the alignment that's causing the weakness or if there's another component issue. But at this point, the testing I've done suggests the alignment is substantially off. Okay, that's good. That's good for today. That's enough for me. It's another nice day outside. Got to get out there. And I hope your day goes fine. Stay safe. Wear your mask. Go get vaccinated. All that stuff. And I'll see you on the next video.